networks. Fifth, we have Cat5. Yung maximum data rate is 100 Mbps to 1000 Mbps or 4 pairs. It provides performance for all data and phone systems and has become the standard for high-speed applications. So same lang sila sa 5E, no? And next, we have Cat6. Yung maximum data rate is up to 250 Mbps and it is extremely fast, broad applications. So kusog na kaayo ni siya, no? And lastly, we have Cat7, ang pinakakusog sa tanan which is up to 600 Mbps iyang maximum data rate and it is super fast broadband applications. So mauna siya ang table 22.2 which is ang categories of twisted pair cabling. Moving on to the last topic, we now have RJ45 connectors. RJ45 connectors are the standard female connectors used in a telecommunication system for UTP cable. A slot allows the RJ45 to be inserted only one way. And RG stands for registered jack, implying that the connector follows a standard borrowed from the telephone industry. The RJ45 is an 8-pin connector used for data transmission or networking and some business telephones. Pins are numbered 1 through 8 with a locking clip at the top. So, mao na siya inyong makita sa picture, no? Kanang mga numbers niya is mao na siya ang mga pins 1 to 8 respectively. And kaning RJ45 na connector is commonly connects to the end of Cat5 cable which connects between a computer network card and a network device such as a network router. And telephone connectors referred to as RJ11 or RJ12 have 4 or 6 pins respectively. Ang RJ11 is commonly known as a modem port, phone connector, phone jack, or phone line. RJ11 is a 4 or 6 wire connection for telephone and modem connectors in the US. So pare-pareho lang ang RJ11 ug RJ12 tungod kay same sila nagamit og 6-slot connector and the only difference lang is kung unsaon sila pag-wired dayon ang number sa wires nga gigamit. And finally, that ends my report, sir. And the next reporter will be Justin Braille Takandong, and he will continue to discuss the different types of transmission media. Thank you so much, everyone, for listening.
Good evening, everyone. I am Justin Baralbita Kandong, and I'm going to discuss the second, third, and fourth type of transmission media. So, since na-report naman ang first type, which is the copper wiring, so mo-proceed na ta sa second, which is the coaxial cable. So, next slide, bro. So, coaxial cable has an outer plastic covering containing an insulation layer made of PVC or Teflon and two parallel conductors, each having a separate insulated protection cover. The coaxial cable transmits information in two modes: the baseband mode, or the dedicated cable bandwidth, and broadband mode, or the cable bandwidth is split into separate ranges. So, the difference between baseband and broadband is that baseband mode transmits a signal stream channel at a time, while broadband transmit multiple data signals streams channels simultaneously at the same time. So next, this is the figure of a coaxial cable. The plastic cover, insulator, outer conductor, shield, insulator, and the inner conductor. Next slide, bro. So there are also advantage and disadvantage on using a coaxial cable. So the disadvantage include the advantages include: first, high bandwidth, meaning high range of frequencies within a given band, in particular that used for transmitting a signal. Second, better noise immunity. Third, easily to install and expand. And last, it is inexpensive. So ang example de daning coaxial cable is kanang TV wire. Yeah, TV wire. Kanang sa gani antenna gani. So next, the disadvantage. Single cable failure can disrupt the entire network. Next slide, bro. So the third type of transmission media is the optical fiber cable. Next slide, please. So optical fiber cable uses the concept of reflection of light through a core made up of glass or plastic. The core is surrounded by a less dense glass or plastic covering called the cladding. It is used for transmission of large volumes of data. The cable can be unidirectional or bidirectional. The WDM or the wavelength division multiplexer supports two modes, namely the unidirectional and bidirectional mode. Next slide, bro. So this is the figure of an optical fiber cable. The outer jacket, fiber core, the loose buffer, and the cladding. So cladding mo ni siyang mo support. Next slide, bro. There are also advantages and disadvantages on using a optical fiber cable. So first advantage, increased capacity and bandwidth. Second, lightweight. Third, less signal attenuation. Fourth, immunity to electromagnetic interference. And last, resistance to corrosive materials. So meaning aning resistance is the ability to protect the substrate from corrosion. And also it has disadvantages. First, difficult to install and maintain. Second, high cost. And third is fragile. Next slide, bro, please. So the last type of transmission media is what we call the unguided media or the wireless transmission. Next slide. So unguided media, also referred to as wireless or unbounded transmission media. No physical medium is required for the transmission of electromagnetic signals. It has also features. First, the signals is broadcasted through air, less secure, and best for larger distances. Next slide, bro. There are three types of signals transmitted through unguided media. So first, ani is radio waves. Examples sa radio waves is radio broadcasting. Ay also cellular networks. Example po na siya sa radio waves. So these are easy to generate and can penetrate through buildings. The sending and receiving antennas need to be aligned. So frequency range from 3 kilohertz to 1 gigahertz AM and FM radios, and cordless phones use radio waves for transmission. So the second, next slide, bro. Muna siya ang figure sa radio wave. Next slide, bro. So second type of wireless media transmission is the microwave. It is a line of sight transmission. The sending and receiving antennas need to be properly aligned with each other. The distance covered by the signal is directly proportional to the height of the antenna. Frequency range from 1 gigahertz to 300 gigahertz. These are majorly used for mobile phone communication and television distribution. Example aning microwave are weather satellites, Bluetooth, and Wi-Fi. So the type of wireless media transmission. Next slide, bro. Next slide, please. So that type is the infrared. So example ang infrared or cordless system, night vision system. Infrared waves are used for very short distance communication. They cannot penetrate through obstacles. This prevents interference between systems. So the frequency range from 300 gigahertz to 400 terahertz. It is used in TV remotes, wireless mouse, keyboard, printer, etc. So that's all for my topic. Thank you for listening.
Good evening, everyone. Good evening, sir. I'm going to discuss the electromagnetic interference. So what is an electromagnetic interference? Electromagnetic interference, or EMI, is unwanted noise or interference in an electrical path or circuit caused by an outside source. It is also known as radio frequency interference, or RFI. EMI can cause electronics to operate poorly, malfunction, or stop working completely. Ang EMI daw kay mahimong tungod sa natural o hinimo sa tao. So EMI can be caused by natural or human-made sources. Electrical current flow in power lines generates an electromagnetic field that surrounds the electrical conductor. Electrical equipment, especially large motors, generators, induction heaters, arc welders, X-ray equipment, and radio frequency, microwave, or radar sources also produce a powerful electromagnetic field. The ballast of fluorescent and high-intensity discharge, or HID, fixtures also produce a significant electromagnetic field. A telecommunication cable placed within an electromagnetic field will have its telecommunication signal affected. This is known as electromagnetic interference. And so, because of potential for electromagnetic interference, voice and data telecommunications cabling should not be run adjacent and parallel to power or electrical cabling unless the cables are shielded and grounded. For low voltage telecommunication cables, a minimum of 5 inches or 125 millimeters distance is needed from any fluorescent lighting fixture or power line over 2000 volt amperes and up to 24 inches from any power line over 5000 volt amperes. In general, telecommunications cabling is routed separately or several feet away from power cabling. So layo siya. Ang telecommunication cabling daw kay separate or layo siya sa power cabling. For similar reasons, telecommunications cabling must be routed away from electrical equipment. Examples of EMI or electromagnetic interference are disturbance in the audio or video signals on radio or TV due to an aircraft flying at a low altitude. Next, noise on microphones from cell phone, handshaking with communication tower to process a call. Next, a welding machine or a kitchen mixer grinder generating undesired noise on the radio. Last in flight, particularly while taking off or landing, we are required to switch off cell phones since the EMI from an active cell phone interferes with the navigation signals. And the other examples of EMI are the following: RFI or radio frequency interference, TVI, television interference, radio noise, electrical noise, crosstalk, and etc. As you can see in this figure, these are some of the real-time example of electromagnetic interference that we can see in our day-to-day life. Let us discuss about one of the real-time example, EMI environment, that is crosstalk. From transmitter side, multiple telephones are connected through a switch model. With the help of an optical fiber, and the signal is received by the LAN. In this criteria, when a person is communicating with another, sometimes the signal may get lost or interfered with some other signal that may result in crosstalk or loss of data due to some of the resources like radio and TV broadcast, power lines, lighting, and etc. Similarly, during the rainy season, by watching television, the signal gets discontinued due to the natural calamities. This is another type of interference caused by the natural sources, which affects the electronic system. That's all. That's all about the electromagnetic interference. So let's have Miss Jovi Aksindi Kailing to discuss the 22.2 structured building telecommunication system.
So good evening everyone. My name is Joey Aksindi Kailing and tonight I will be discussing about structured building telecommunication systems with the topic wiring and cabling standard, telecommunication cabling and pathways, and the structured cabling systems. Next. So wiring and cabling standard. The EIA, Electronics Industries Alliance, TIA, Telecommunications Industry Association, and the large consortium of leading telecommunications companies work cooperatively to create the American National Standards Institute, ANSI TIA EIA 568-1991 Commercial Building Telecommunications Wiring Standard. Additional standards documents covering pathways and spaces, administration, cables, and connecting hardware were subsequently released. The ANSI TIA EIA 568-1991 was revised in 1995 and is now referred to as ANSI TIA EIA 568A Commercial Building Telecommunications Cabling System that can support virtually any voice, imaging, or data application that an end user chooses. So, ngano na-establish man nga standard? That is because sa una, ang mga manufacturers pa ang ga-control sa mga specifications sa telecommunications cabling. And accordingly, end users and manufacturers have conflicts regarding sa transmission performance na poor quality. Kay sa una man good, ilahang cabling system is traditional kung asa unorganized kay lang cables, tas dili kay siya well structured, tas tag-as pa jud kay bayron nun sa mga installation. And to address this issue, the communications industry recognized the need to define a cost-effective, efficient cabling system that would support the widest possible range of applications and equipment. Next. So, unsa man ni ang ANSI TIA EIA 568A Commercial Building Telecommunication Standards? So, kana siya nga document was created and is regularly updated to provide the communications industry with a standards-based structured network cabling platform that will support a wide range of communications applications. So, this is originally adopted in 1991 as EIA TIA 568. And the 568A is approved in October 1995, which replaces the 568. So, muna siya ang contents ani nga document. We have the structured cabling topologies, cable distances, installation and grounding guidelines, cable media, work area defined, telecommunication equipment room and entrance facility location, functions and design, 100 ohm UTP cabling system, optical fiber cabling system, hybrid and undercarpet cables. So kano siya nga document ga undergo og revisions kay naay mga parts na gipang update or enhance ba kaha kay and naapoy gipang dugang, and since gaka-advance pod ang atong system kay naaman taron sa modern period, baka-upgrade pod ang atong technology. That is why we need an updated cabling system pod to adapt sa change. Next. So, based sa ako na research, mao ni ang latest version nila sa document, which is TIA 568.1E, the 2020, which is entitled Commercial Building Telecommunications Infrastructure Standards. So, as you can see, daghan na siya content compared sa 1995 na version. And the contents niya we have coverage area, multi-tenant building spaces, cabling installation requirements, cabling transmission performance requirements, cabling for wireless access points, grounding and bonding, telecommunications pathways, power stopping, administration, and physical network security, to name a few. I don't know if naabay national na standard diri sa Philippines, but based sa akong na-watch na YouTube lecture regarding ani, Philippines is ga-adapt pud ani nga international standard. Next. Next, we have telecommunication cabling and pathways. So, telecommunication cabling is the medium through which voice and data move from one telecommunication device to another. Cabling physically carries electrical or optical signals to and from devices and equipment in a telecommunication system. So, ang telecommunication cable is a type of guided transmission mediums. Ginagamit ni siya to enable two-way communication over long distances by transferring information from one spot to another. Ang cabling media typically used here include UTP and shielded twisted pair and STP shielded twisted pair copper wire, coaxial cable, optical fibers, and wireless technology. So there are two elements of the telecommunication cabling structure. We have the backbone cabling and the horizontal cabling. So let us first discuss the backbone cabling. Next. So we have here the backbone cabling. It is defined as cables having more than 4 pairs of 22 AWG to 24 AWG solid conductors with a thermoplastic insulating cover. The function of the backbone cabling is to provide interconnection between telecommunications rooms, equipment rooms, main terminal space, and entrance facilities in the telecommunications cabling system structure. It consists of the backbone cables, intermediate and main cross-connects, mechanical terminations, and patch cords or jumper used for backbone-to-backbone cross-connection. So, muna siya mga recognized cables used in backbone cabling. First is the 100 ohms twisted pair cable. Number 2 is the multi-mode optical fiber cable. And number 3 is the single-mode optical fiber cable. So, based sa picture na inyo nakita ron sa screen, ang kanang gitudlo sa arrow is the backbone cabling, which is also known as vertical cabling due to the area it covers. So, as you notice, the connection started from the first floor kung asa naadara ang atong main distribution facility, and then naay cable run na nakakonect from that floor to the following floors na dayon sa building. So, yung connection ani is floor to floor. Next. So, a backbone is a generic term used to describe a main pathway or cabling media that interconnects a number of telecommunication devices. A backbone is used to connect networks in a building or in separate buildings. Then fiber optic cable is typically used for this type of backbone. So common kini siyang fiber optic cable na gamiton since it covers large distances. And transmission is faster for fiber optic. So next, we have here table 22.5. So these are the common types of backbone cabling in use. Under sa cabling types, we have twisted copper wire and optical fiber cables and its respective maximum backbone distances in meters and feet. So why is it na need nato ma-establish ni ang maximum distance? That is because this maximum are the best possible rating the cable is capable of under theoretical perfect conditions. Kaya another key factor man good for signal quality is the distance of the cable. So if manlapas sa limitation, na tendency na poor ang transmission performance kay the farther a signal has to travel, the more it will degrade man. So by the time it gets from point E to point B. So it's much better and safer to stick adding a limitation to ensure good quality of transmission performance. Next. So after sa backbone cabling, we have horizontal cabling. The cables here shall be 4 twisted pairs of 22 to 24 AWG solid conductors with a thermoplastic jacket and shall meet the requirements of ANSI ICEA or the Insulated Cable Engineers Association S8576 where applicable to a 4-pair inside wiring. The horizontal cabling is the portion of the telecommunications cabling system that extends from the work area telecommunications room. So note that the term horizontal is used since typically the cable in this part of the cabling runs horizontally along the floors or ceilings of the building. So muna siya ang recognized cables used for horizontal cabling. First is the 4-pair 100 ohm unshielded twisted pair UTP or the screen twisted pair SCTP. And number 2 is the 2 or more optical fiber multi-mode cable. So as you can see sa picture, horizontal cabling is structured in a horizontal manner. And kanang color green na line, muna siya ang horizontal cabling where it connects 2 points from the telecommunications closet or room to the communication hardware, devices, and equipment sa inyong work area. Well, that red colored na line is the backbone cabling. So mao na ilang difference nila dua, ang ilahang area na gina-cover. Next. So a pathway is a passageway and thus a path for a cable to travel when interconnecting devices, components, and equipment in a telecommunication system. Pathways are typically a raceway, a channel, or through designed to hold wires and cables. In a building telecommunication system, pathways typically run between the building entrance facilities, equipment rooms, telecommunication closets, and the work area where telecommunication equipment and devices are used by building occupants. So, importante jud na naatay pathway for cable management, kay aside sa lain kaayo tan-awon ang unorganized o nagkalambod-lambod na cables, it will be at a greater risk pod of damage if they are not properly secured. So that is why needed siya in order to enclose the cable to protect them from heat, dust, light, moisture, and harsh situations. Next. So some of the common pathways are cable tray, electrical metal tubing, underfloor raceways, wireways, busways, and ventilated flexible cableways. Next. So we have here the structured cabling systems. So a structured cabling system is the cabling, devices, and equipment that integrate the voice, data, video, and electronic management systems of the building, such as the safety alarms, security access, energy management and control systems, and so on. Design and installation of structured cabling systems adheres to national and international standards. So, it is important to have structured cabling system, especially sa mga commercial buildings, mga data centers, and IT companies since it provides a reliable and versatile solution to a wide range of communication requirements. And also, since karon nga panahon, there is a high risk of human error man jud and mistakes di jud na malikayan being made with the multiple and organized cabling structures, which can cause workflow disruptions and network downtime. So as aforementioned, a well-planned cabling system also means easier troubleshooting, so it's easier to identify and rectify faults quickly. Next. So in commercial buildings, a structured telecommunications cabling system include the 7 subsystems: the interbuilding backbone, building entrance facilities, telecommunications equipment room, telecommunications closet, backbone pathway, horizontal pathway, and work area. So figure 22.2 is a schematic of a structured telecommunications cabling system. So that is how a structured telecommunication system look like kung asa present dira ang mga labels sa 7 subsystems, and these 7 subsystems will be discussed thoroughly by my groupmates for the next part of this report. And that's all for this part, and thank you for listening.
So, good evening everyone. So, madunggan na ba? Kira? So, akong report is katong sumpay ni Ma'am ay Miss Kailing, which is interbuilding backbone, building entrance facilities, telecommunications equipment room, and telecommunications closet. So, next. So, first, interbuilding backbone. So, what is interbuilding backbone? It is the cabling and pathways outside of the building, including the cables carrying local exchange carrier or LEC services. Examples of this are outside telephone company. Next is internet service providers services and private branch exchange or PBX telecommunications cables or private phone network between buildings at school, campus, or business park. So kining inter-building backdoor. So mo ni siya ang cabling pathways nga mag-provide og connection between building to building. So mo na ang ginadayanan niya nga kana ay mo siya dalan bitaw pa sa connections nga katong para sa telephone company, internet providers kana. So next. So divided into two. So first ay interbuilding and intra-building cabling. So while interbuilding backbone wiring is installed between buildings, intra-building cabling is installed between IT rooms within a single building. So, ang interbuilding ko no, kay between two buildings, and ang intra is within the building. So, kung makita ninyo sa picture, from building A to building B, mo na siya ang interbuilding. Ang kanang sa building B, kanang mga cabling diya, mo po na ang intra kay within o siya sa isa ka building. So next. So next is building entrance facilities. So the building entrance facility is an entrance to the building for both public and private network service cables. It includes the cables, connecting hardware, protection devices, and other equipment needed to connect the interbuilding backbone cabling to the backbone cabling in the building. So dali okay siya guys, mo pa gini siya ang mag-entrance bitaw atong mga cables, di ba naman ti interbuilding backbone. So ma-connected gina siya sa kanang building entrance facility. So diya gina siya mosulod. So next. So di ba mao ni? So from other buildings mosulod siya kanang mga LAN and voice equipment napoy uban sa phone company. Mosulod gina siya sa entrance facility. So mo gina ang iyang kanang ibali entrance. So mo galing entrance facility. So sa right side mo po na ang example sa mga entrance facility mo siya dako kay nga box bitaw. So next. So next is telecommunications equipment room. So a telecommunications equipment room is a centralized space for housing main telecommunications equipment. It is a large, dedicated, centralized room that provides a controlled environment to house equipment, connecting hardware, splice closures, grounding and bonding facilities, and protection apparatus. So, dili gina kanang hanay ang mga equipments bitaw, hanay pag distribute ang mga cables padulong sa mga work areas. So, murag kung sa nagpadala pa kami sa sortation center daw, murag diya sa ginahan ay tanan about sa mga telecommunication equipment para kanang basta siya sa pag-distribute sa facility. So napon ni siya kanang industry standard ang kadako sa telecommunications equipment room, which is 0.7 meter squared for every 9 9 meters squared of work area. So kung mas dako imong work area, mas dako pud ang imong telecommunications equipment room. Tapos ang iyang pultahan pud ana kay dapat baga og fire rated. So ang fire rated, di ba, kay kanang mga uh, construct consists of materials nga mag-work together to slow or stop the spread of flames, smoke, and in certain applications, radiant and conductive heat transfer. So, mo to siya. So, next. So, the equipment room should be located away from sources of electromagnetic interference. Examples ana kay transformers, motors, X-ray equipment, induction heaters, arc welders, radios, radar systems, and so on. And air conditioning should be provided 24 hours a day, 365 days a year at a temperature of to 30% to 55% relative humidity. So general lighting of 50-foot candles at 3 feet above the floor and a minimum of 2 dedicated 15 ampere 120 volt AC duplex convenience receptacles on separate circuits should be provided. Additional duplex convenience receptacles should be placed at a 6 feet or 2 meters intervals around the perimeter. And emergency power should be considered and supplied. So mo to dapat i-maintain nato ang temperature ng equipment room nga kay basin ko mag-init, masunog mga na. So unsa siya. So next. So mo na yung equipment room mo. So sa makita ninyo natay backbone cables from entrance area. So ang entrance facility og telecommunications equipment room day guys kay dapat usa ra kay para parehas mausa ra sa mga air conditioning, mga lighting ana. So na dire ang wag dire siya sugod bitaw tanan, wag na siya distribution cross connect. So di na din di pang distribute sa mga facilities. So mo gina yung mga common nga nasa equipment room. So next. So telecommunications closet. So a telecommunications closet is a dedicated room on each floor in a building that houses intermediate voice and data, telecommunications equipment, and related cable connections. A large building will have several telecommunications closet and more than one on a floor. The telecommunications closet should be located in a space that is central to the work areas it serves. So next. So each telecommunication closet serves as a location where junctions between the backbone pathway and horizontal pathways are made at one or more patch panels. So a patch panel is a mounted hardware unit containing an assembly of rows of connecting locations in a communication system called ports. A port is a receptacle that is a specific place for physically connecting a device or piece of equipment to another. In a network, a patch panel is located in a telecommunications closet to serve as a type of switchboard-like device that allows network circuiting arrangement and rearrangement by simply plugging and unplugging a patch cord. So, di ba kay naaman tay equipment room. So, i-connect din nato siya padulong sa telecommunications closet. So, sa each floor sa isa ka facility or building. So, kanang telecommunications closet. So, next sagali, please. So, muna siya ang atong telecommunications closet. So, kana siya, naana siya patch panel. Kanang naa sa right, mo na ang patch panel. Tapos, aga na magbangag-bangag, bitaw na, mo na siya mga ports. Tapos, kanang mga ports na i-connect ana kay patch cord. Tapos, kanang patch cord, mo na din na ang maghatag o connection sa work area or work area ana nga floor. So, next. So, mo na yung magsama niya. So, di ba, natay interbuilding backbone, kini nasa lower right. So, diya ang sugod. So, from other building or facility. So, musulod na siya sa building entrance, which is, nakausap na siya sa telecommunications equipment room. So, mapadulong din na siya sa ato ang mga telecommunications closet. Kita ninyo, pinaagi sa mga kanang backbone pathway cabling ana. So tapos kanang telecommunication closet dayon, di ba naman nakita ninyo na sa each floor. So kana dayon ipadulong din na niya sa mga sa work area. So ingana man na siya. So interbuilding backbone mapadulong siya sa mosulod siya sa entrance facility, sa equipment room dayon, then sa telecommunication closet dayon to the work area. So to ako. So next reporter.
Good evening, everyone, again. So, I will be discuss or the continuation of the fifth, sixth, and seventh subsystem of structured cabling systems. So, backbone pathway. Within a building telecommunication system, the backbone pathway connects the entrance facilities or equipment room to the telecommunication closet for cabling that interconnects equipment and devices in these spaces. It contains several backbone or main cables that carry the heaviest telecommunications traffic throughout the building. It is usually a vertical arrangement that connects floors in a multi-story building. However, the same function may be served by a lateral backbone for horizontal distribution in a large building with spacious floors. Sa makita ninyo sa photo 22.9, mo ni siyang example na wall-mounted telecommunications panels, Russian cabinet or box. A building's backbone pathway consists of the backbone cables, intermediate and main cross connects, mechanical terminations, and patch cords used for backbone-to-backbone cross connection, connections between floors or risers, and cables between an equipment room and building cable entrance facilities. The backbone pathway can hold any type or combination of transmission media, but cabling typically includes UTP, STP, and optical fiber cable. Backbone cabling distance are dependent on the type of system, data speed, and the manufacturer's specifications for the system's electronics and the associated components used. Example, adapters, line drivers, and so on. All cables in the backbone pathway are typically strung in a star topology. This configuration allows modifications to be made without the hassle of having to pull new cables. See photos 22.10 to 22.12. As you can see in photo 22.10, that is the horizontal backbone cabling in a wire tray. And photo 22.11 is a bundled horizontal backbone cabling, Cat3 PBX telephone cable, Cat5A, 5E data transmission cable, interduct shearing containing fiber optic cable, and two bundled interduct shearings containing fiber optic cable. And photo 22.12 horizontal backbone cabling entering a firewall. The openings are sealed with an approved fire-stopping material. Now, what is horizontal pathways? Horizontal pathways connect the backbone cabling entering the telecommunication closet with the terminal equipment in the work area. Example, computers, data terminals, telephones, and so on. Horizontal pathways can include underfloor ducts embedded in concrete decks or slabs, modular or cellular or raised floors, underground trench ducts, and raceways. Example, conduit, cable trays, it says molding. A raised floor system is shown in photos 22.13 and 22.14. So in a photo 22.13, raised floor system is open containing cabling, while in photo 22.14, raised floor system closed. The most commonly used horizontal pathway consists of cable bundles run from the telecommunications closet along J-hooks or cable trays suspended above a plenum ceiling. Once a work area is reached, the cabling fans out and individual cable drops through interior walls, support columns, or chassis, eventually terminating at the telecommunications outlet. The horizontal cabling system extends from the work area or workstation outlet to the telecommunications closet and consists of horizontal cabling, telecommunications outlet or cable terminations, and cross connections. Types of media used for horizontal cabling include UTP, STP, and optical cable, each extending from the telecommunication closet to the work area at a maximum distance of 294 feet or 90 meters. So for more information about backbone and horizontal pathways, the network in Figure 4 is perhaps the simplest example of what's known as a structured cabling system or SCS. Pero walay nag-ingon ani nga kani siya nga figure di ay kay usa siya or ginatawag siya nga structured cabling system. Kay because it would have to include all of the connecting hardware, mounting hardware, blueprints, testing procedures and results, and much more. But it suits our proposals here because that kanang color red nga line connecting two switches mo na siya tong ginatawag nga backbone cable. In those blue lines connecting the switches to the devices symbolize the function of horizontal cables. Horizontal cabling. In figure 5, the horizontal cabling is again shown in blue lines. These are the cables that are permanently connected to a patch panel in a telecommunications room on one end and two wall or ceiling jacks on the other end. Then those permanent links are connected to an access switch in the same telecommunications room. While backbone cabling, in figure 5, the backbone cabling is shown in white. Ano yun, nasa kilid, right side. Since all of these backbone cables are contained within the same building, they are called intra-building backbone cables. So, ano siyang ginatawag na itong intra-building backbone cables. Each backbone cable leads from the access switch or switches in a telecommunications room to another room where they all connect to another switch. Note that even though these backbone cables are running mostly parallel to each other, they all connect to the same switch in the logical center. Therefore, this is still an example of star topology. And the seventh subsystems are work area. The work area is the space containing workstation or terminal equipment and components. The workstation components include equipment and devices. Example, telephones, personal computers, graphic or video terminals, fax machines, modems, and terminal patch cables. Example, modular cords, PC adapter cables, fiber jumpers, and so forth that connect work area equipment to the network. Work area wiring is designed to be relatively simple to interconnect so that modifications and additions can be easily accomplished. The work area can also be served by a wireless access point. See photos 22.15 through 22.19. As you can see in photo 22.15, it is a wireless access point station. In photo 22.16, a work area above a raised floor system. In photo 22.17, a workstation. Muna siyang workstation na to. Like, nasa yung computers and so on. In photo 22.18, a workstation connection with telecommunications and power outlets. While photo 22.19, a telecommunications outlet with coded female connections. The work area. A typical telecommunications outlet is made in a 2 inches by 4 inches or 50 millimeters by 100 millimeters electrical box with horizontal cabling terminating at a connector on the faceplate covering the box. It is necessary to consider the number and type of devices to be connected when selecting the outlet, capabilities, and capacity. In industry practice is to provide a minimum of 2 telecommunications outlets or connectors at each work area. At areas where telecommunications use is anticipated to be heavier than normal, example, reception areas, secretarial areas, and control desk areas. Additional outlets will be required. Patch cables connect work area equipment and devices to a telecommunications outlet. A maximum length of 33 feet or 10 meters is typically allowed for work area patch cables. So that's all. Thank you. So let's have Miss Nahiel to report the last advanced home wiring system.
Good evening, everyone. So I'm the last reporter, and I'm going to discuss about advanced home wiring systems. Next. So advanced home wiring system. An advanced home wiring system allows a homeowner to integrate the control and management of the following subsystems. So we have 5 subsystems. The first subsystem is the communication subsystem. So mao ni siya ang intercom, phone, message recording, fax, and email. So next subsystem is the entertainment. So diri ang mga whole house stereo, VCR, cable, digital, and satellite television, and home theater system. So the next is home office subsystem. So mao ni siya ang mga computers, printers, and scanners. So the next is environmental control or energy management subsystem. So diri ang control of heating, ventilation, and air conditioning o kanang mga heater, lighting, and other appliances. And the last subsystem is the security property protection subsystem. So diri mao ning kaning mga CCTV, control entry gates, and garage doors, control loan
irrigation. So next son. So wiring system components. An advanced home wiring system is typically consists of three main components. These are the service center, universal multi-use outlets, high performance cabling. Wait lang. Sorry ako pang gipagawa sa kong iring. Service. So the first component is service center. So the service center kay ginatawag po ni siya usahay nga central hub or distribution center. It is the central part of the system that accepts incoming services and distributes services throughout the home. So diri tanan klase sa external communication services nga gasulod sa atong residents including cable TV, telephone, digital satellite transmission, and internet service. It serves as a central hub that distributes these services to location throughout the house in a way similar to how an electrical panel board distributes and control flow of electricity. So kaning naa sa picture mo ni siya ang example sa service center. It is a standalone piece of equipment that contains distribution devices. It provides universal access to various networking elements within the home as well as connection to service providers. The service center must allow the wiring system to be customized periodically as the network evolves to accommodate future technologies. So ang kaning service center kay dapat located siya sa kanang place nga accessible o ready to cabling maintenance. So next son. So the next component is the universal multi-use outlets. The telecommunication outlets in a room determine the services that are available in that room. Universal multi-use outlets can be customized to a customer's specific needs based on the services that are desired in each room. Example, kaning mga cable, internet access, telephone, and so on. So these outlets are designed to support a full range of communication technologies with a variety of flexible configurations, including voice, data, and video. So even after the wiring system installation is complete, outlets can be changed to meet the changing needs of the homeowner. The next one. So the last component, high performance cabling. So several types of high performance cable are used, including CAT5 UTP copper wire and coaxial cable. And also wireless transmission can be used. So naa sa libro wala lang nabutang sa dari sa PPT nga in the future fiber optic cable may eventually become a medium of choice for some audio video applications. It is because fiber optic cables have a much greater bandwidth than metal cables, and the amount of information that can be transmitted per unit time of fiber over other transmission media is its most significant advantage. An optical fiber offers low power loss, which allows for longer transmission distances. Pathways for cabling run between the service center and the outlets. For new construction, cable is run in concealed pathways such as ducts and conduits. Provisions should also be made for conduit for cable pathways to allow for pulling additional wiring in the future. For retrofits of an existing structure, Wiring can be concealed in attics or crawl spaces wherever possible. While for exposed retrofit cabling, the cables should be enclosed in a protective surface mount raceway. And that's all for advanced home wiring system and wiring system components. Thank you for listening.
Okay, thank you sa report, Group 6. Na kasabot ra ba tanan sa ilang discussion or namoy mga questions? So, I guess wala siguro, no? Madali lang. Sa mga na ako'y ihatag nga assignment sa inyo ha. Posted na siya sa USTEP. Ang deadline niya is on May 25, 6 p.m. Tulo ra to siya ka questions, inyo ra tong ansiran. Dali naman to. Tapos by next week, maghatag ko og quiz sa inyo ha. Ang topic na to is ang gidiscuss karong gabi, telecommunications. So, ang quiz is most likely after sa discussion sa report. Kay naman yung mag-report next week. So, andam lang ta. So, for now, natag na akong assignment, no? Tapos mag-quiz. Okay, so, kung wala na tayo questions, no, na ako'y gi-assign ako ang group 6 nga maghatag og seatwork sa inyo, ha? Ang deadline for the seatwork is koan. May Mayo anyway. Ugma 8 AM. Nakuha ba to na to? Saan?
Noted, sir.
Saan? Pakita daw sila sa ano? Sa atong kuan, ansira nila for seatwork.
Okay, sir.
So, mo na ang inyong ansiran guys for the seatwork. So, deadline ani is tomorrow 8 AM. So, kaya raman kung nakapaminaw mo sa discussion nila, maka-answer man din mo. So, ni siya ipasa. Mag-post lang ko sa USTEP para asa ni siya ipasa. Dito na lang ipasa din sa USTEP, guys. Reporters, exempted money ha. So, bali, quiz. Ang quiz next week, exempted po mo. Pero ayaw po magpalimot pasa sa katongkan na file nga indication na exempted mo.
Noted, sir.
So, mga non-reporters, ano tayong mga questions so far? So, kung wala na, no,
Adi-
pwede na.
Wala na, sir. I guess wala na, sir.
Yes, sulaton gyapon. Handwritten siya. Okay, sa question lain. So, I think wala na, no? So, pwede na tayo mag-class dismiss. Thank you sa pag-attend sa ato ang klase karong gabi and maayong pagpanihapon sa inyong tanan.
Thank you, sir. Good